This video is going to be all about radical expressions. And a radical expression is simply something that has an expression that has the radical symbol. And in this case, we're only going to deal with the square root symbol. There are more complex radical symbols, cube root, fourth root, but we're only going to deal with the square root. Now, the first thing is to know how to simplify a complex radical. And so we'll just go through a bunch of examples pretty quick, and I'll show you just the different tips. First of all, you always want to simplify what's inside of the radical. You want to simplify what's inside the radical. So here in this case, I can reduce 2 over 72 to 1 over 36 because they're both divisible by 2. And then I can just take the square root. And when you take the square root of a fraction, you just take the square root of top and bottom independently. So the square root of 1 is 1, and the square root of 36 is 6. And that's it. That's my answer. 1, 6. Again, no matter what you're doing, you always got to simplify the inside. And sometimes people just want to see, oh, square root, square, I just cancel those. No, no, no. Simplify the inside first. Simplify it first. So what I got to do is I got to square that, square that. That's going to be 9 plus 16. And then I got to add 9 plus 16. And I get 25. And then I take the square root. Once it's all simplified, now I can take the square root, and the answer is 5. Square root of 25 is 5. If I had taken a shortcut and just tried to eliminate these square roots and tried to do 3 plus 4, that is not correct. As you can see, the answer is 5. So you've got to simplify what's inside first. Simplify what's inside first. Now, in some crazy situations, they're going to give you something like this. Well, you can't combine these. You can't simplify them. And you can't just take the square root of each part separately. We just found that out. That's not okay. So if you get something like this, it's because they want you to factor. And for the sake of time, we're not going to go through how to factor. But I'll just let you know that this expression right here, x squared plus 4x plus 4, would factor as x plus 2 times x plus 2, or in other words, it would factor as x plus 2 squared. Now, because I have a parentheses, the whole thing is squared, and then I'm taking the square root of the whole thing. Now that will cancel, and all I'll be left with is x plus 2. Now, there's some technical things that this is not technically correct yet, and we're not going to fully explain it, but I will tell you this. If it says simplify, and that's all it says, and there's a variable involved, just be safe. Throw in an absolute value sign around your answer. And that's just to prevent this part from becoming negative, because remember, you can't take the square root of a negative. And so that's here. Here, if it's a simplify, but then it adds this little caveat that says all variables represent non-negative numbers, that means, well, hey, if I get an answer with an x in it, well, it's not negative, so I don't have to worry about that absolute value thing. So, as a general rule of thumb, if it just says simplify, and it's got a letter in it, a variable, just throw in some absolute values. And if it says all variables represent non-negative numbers, don't worry about it. That's sort of the really simplified short version. If you have more questions and more depth questions about that, I can answer those in class. So here we got some more here. Square root of 18. Well, this is already simplified, and I can't take the square root of it. Unlike this, I simplified and then took the square root, simplified, took the square root, factored, then took the square root. Here, it's already simplified, and I can do nothing with it. So what you can do is you can actually split the radical into multiple pieces. So the square root of one number times another number. And what you're looking for this first number is a number that you can actually take the square root of. And just so you know, there aren't a whole lot of numbers you can take the square root of. 1, which won't help us, but 4, 9, 16, 25, 36, 49, 64, 81, 100, 121. As you can see, as you get more and more complex here, and higher up the scale, Wait, I missed, next one, there we go. 196 and 225, we'll stop there. That's 15 squared at the end. As you can see, this is Algebra 1, right? They're not going to throw a bunch of these numbers necessarily at you, but you're probably going to deal with these ones a little bit. And so my question is, do any of these numbers go into 18? I need a number that I could take the square root of, and that's the list. There aren't other ones, unless you get a lot bigger numbers. Well, which one of those goes into 18? The only one on that list that goes into 18 is 9. You can take the square root of 9, and 9 goes into 18. So I'm going to put 9 there, and the number I put here is the number I need to make it work. So what's 9 times what is 18, and that would be 2. So to sum it up, you're finding something on that list of things you can take the square root of in one box, and then whatever you need to put here to make it still the same as it was before, that's what you do. And then the next step is to simply take the square root of the thing that you can. So the square root of 9 is 3. Notice how the square root disappears, because I took the square root, it's gone. And I can't take the square root of 2, there's nothing I can do there, and that is my answer. So this is a this might seem kind of crazy to call this simpler than this, but this is the standard form for writing radical expressions. That you take everything that you can out of the radical expression. And so the square root of 18, if I were to simplify it or write it in standard form, would be 3 times the square root of 2. All right, now, what about for letters? Same idea. What part of the letters can you take a square root of? And remember, you can take the square root of anything that's an even power. So here, I can take the square root of x to the 4th. But I can't take the square root of y cubed. But I could take the square root of y squared, and to make up for that, I would have to write a y here. So you'll see that y squared times y is y cubed, but now I have a part that I can actually work with. So if I take the square root of x to the 4th, that's x squared. If I take the square root of y squared, that's just y. And then this I can't take the square root of, that's left over, and that is my answer. So x squared y times the square root of y is the standard simplified form of this expression. Moving on. Okay, looking here. I can't do anything with 5. None of those numbers go into 5. None of them. But I can do something with the 9. So what I'm going to do is I'm going to split this into 2 square roots. I'm going to take the square root of 5 on top and the square root of 9 on bottom, and I can do something with that 9. The square root of 9 is 3. Again, notice how the square root disappears. And I can't do anything with the top, square root of 5. And that's my answer. Okay? So these seem sort of complex at first, but once you get it, once it clicks, they're relatively simple problems. It may take some practice, and feel free to ask questions in class. Now let's go over to something even more complex. Again, you got to simplify, if you can, what's inside first. So here, I have something that will reduce a to the 5th, and that a, if I take away one of those, that would be a to the 4th, and that a would be canceled out. So I'd have a to the 4th over 81. Well, I can take the square root of both of those. The square root of a to the 4th is a squared, and the square root of 81 is 9. And there you go, there's my answer. Okay, again, simplify first. We're going to do the same thing here. The square, if I simplify, these are both divisible by 3. So if I divide 12 by 3, I get 4. And if I divide 27 by 3, I get 9. Well, now I can take the square root of both of those. The square root of 4 is 2. And the square root of 9 is 3. Okay? All right, now for something a little bit more complex. And we're going to see this is going to be a most complex example. First, I can take the square root of 25. So what I'm going to do is I'm just going to write the square root of 25 on the top. I know I can do that. Now on the bottom, I can't take the square root of 8. But there is a number on this list that goes into 8 that I can. And that number is 4. So I'm going to write the square root of 4, and guess what? I can take the square root of x squared, so I will put that in there. And what remains, after all is said and done, is I need a 4 times 2 to get that 8. And so now you can see I have the square root of 25 on top, and this has been broken up. It used to be 8x squared. It's been broken up, so it still equals 8x squared. But now I can take the square root of this piece. Okay, so let me take the square root of the top. That's 5. And the square root of the bottom is 2x root 2. Now, unlike all the rest of these problems, there's actually still something technically wrong with this problem. And that is this. When we standardize a radical, you can never have the radical in the denominator. And so I have a square root of 2 here, and that's a problem. In all these other cases, the square root was either gone completely, or it was in the top, like here. Or there was no fraction at all, like here. But here's a fraction where the square root's in the bottom, and that's kind of like a no-no. You shouldn't have an answer that way. We need a standard form. And so to solve that, this is all that you do. Anytime that you have a radical in the bottom, like this, you're going to multiply both top and bottom by that radical. So it's the square root of 2, multiply the top by the square root of 2, multiply the bottom by the square root of 2. Again, you can always do that with a fraction. Multiply top and bottom by the same, because that's just 1. Multiplying by 1 doesn't change a thing. Okay, now let's see how this works out. So on the top, it's pretty simple. 5 times the square root of 2 is 5 root 2. That's it. Don't overcomplicate it. Just 5 times the square root of 2, and that's it. On the bottom, though, it will always be that if you take the square root of something times the square root of that same thing, the square roots will cancel. Just to give you an example here, if I had the square root of 3 times the square root of 3, well, that's the same as the square root of 9. 3 times 3 is 9, which is equal to 3, which just means that the square roots are gone. That works for every square root. So if I take the square root of 2 times the square root of 2, that's just 2. So together, that's just 2. But I still have this 2x here. So 2x times 2 is 4x. And now I have an answer that is as simplified as possible, and the radical is only on the top.